Three. All right, so it is directed line segment that has magnitude, its length, its direction is the angle made with the positive x-axis. So the way that it would always be set up on a coordinate plane here, we're talking about this is the angle. Okay, that's the direction angle right there. The length there of the arrow or the ray or whatever you want to call it does correspond to its magnitude. Now we're going to get into actually having to calculate these things. So let's add some trig in there. Okay, so here's a similar picture. Here's just a vector that's in the first quadrant. Okay, here's a vector in the first quadrant. So the blue is the vector, but I also have a horizontal distance here and a vertical distance labeled. One thing that we need to be familiar with is what we call component form. Okay, component form of a vector. I call them pointy brackets. Okay, they look like the arrows on the ends. When you see that, it's not representing a point. What it's doing is it's breaking down the vector in terms of its horizontal and vertical components. So it is kind of like a point. Essentially, you got your X and you got your Y, horizontal and vertical, but the pointy brackets there indicate, hey, I'm talking about a vector in component form. Okay. So how do we come up with a component form? If we're just told the magnitude and the angle, how do we end up figuring that out? So we've got our magnitude here, which they use, it looks like an absolute value of, not U, V for vector. Okay, the absolute value of V is what it looks like, but that's representing the magnitude. Essentially what I've set up here is a right triangle, is it not? Here's a right angle. Here is our theta, our direction angle right down here, formed with the positive x-axis, always formed with the positive x-axis. I will keep emphasizing that because that's what trips people up the most on this. All right, so here I've got x, here we've got y, that's supposed to be in green. Okay, so if I'm trying to solve for x and y, how about I use some trig? Okay, how about I use some trig? So let's start with x. If we are trying to solve for x, which would be the horizontal side right here, using trig, if we know theta and we know the magnitude, which trig ratio would we use if we're solving for x? I know theta, and I know the magnitude, aka the hypotenuse. I'm going to use cosine because x is the adjacent. Okay, so the cosine of theta is equal to the adjacent side x over the hypotenuse, which in this case is the magnitude. So if I'm solving for x, I multiply both sides by the magnitude to get my x component. My x component is equal to the magnitude times the cosine of the angle. Here's the nifty thing. You're already used to x and cosine going together, right? From the unit circle. The cosine of the angle was equal to the x coordinate on the unit circle. So that is convenient. So if I'm solving for y, the vertical component, which trig ratio am I going to use? Sine. Sine of theta is equal to y is the opposite from my angle down here over the hypotenuse, which is the magnitude. And to solve for y, again, I multiply both sides by the magnitude. So my y component is equal to the magnitude times the sine of the angle. All right, so we know how to solve for the x component, the y component. Sometimes they might ask us to solve for the angle. They may give us the components and we need to find the angle. So if we know x and y, how could we solve for theta? If we know x and y, how can we solve for theta? Tangent. We'll use the other two. Tangent is equal to the opposite y over the adjacent x, or sine over cosine. Sine is y, cosine is x. Okay, and how do we get theta by itself there? Inverse tangent. Inverse tangent is how we get theta completely by itself. Okay, so that's the setup. Those are the three pieces that we're going to be using a lot to find whatever they're asking us about. So let's do an example like this. Find the components of the vector v with a direction angle of 115 degrees and a magnitude of 6. We have a direction angle of 115 degrees and a magnitude of 6. Now, we really don't have to draw this to be able to answer this question, but I want to because we're going to get to some application problems. And it helps if you see the picture. It's going to help you catch some careless mistakes that people have repeatedly made in the past. So if you draw it, it's going to make more sense. All right, so direction angle of 115 degrees, that's going to put us just past vertical into the second quadrant there. That angle is 115 degrees, and then 6 would be the length of this vector right here. All right, so if we're finding components, our x component is equal to the magnitude times the cosine of the angle. Calculator, okay? Calculator. Make sure it's in degree mode. If it's been reset, it's going to be in radian mode. Oh. Y'all know you're supposed to get those before class starts. Okay, so the x component that it gives us is negative 2.536. That should make sense. We're in the second quadrant. In the second quadrant, our x values are negative. Okay, that part should make sense. So our y coordinate, we're expecting to be positive. And do y'all think it's going to be bigger or smaller than 2.5? Bigger. Why? Why do you think the y component is going to be bigger? Lucky guess? Yeah, 50-50 chance. Look at the angle. It's a steep angle. It's pretty close to 90 degrees. So you got more vertically than you do horizontally. You're closer to vertical than you are to horizontal. So yes, the y coordinate is bigger, and it is positive. Okay, 5.438. Okay, so again, x goes with cosine, y goes with sine. Make sure your calculator's in degree. Okay, what if they give us the components and they want the magnitude? We're going to use the Pythagorean theorem. Okay, it all goes back to that right triangle that it was built from. You know the x component, that's one leg. You know the y component, that's the other leg. So the hypotenuse, square them, add them together, take the square root. So I just wrote it in the context of vectors, but all it is the Pythagorean theorem. Okay? All it is the Pythagorean theorem. So let's look at, I'm going to do one and then I'm going to let you do one. If I give you the component form, let's find the magnitude and direction angle. Again, you don't have to draw it, but let's draw it to see if we can catch any mistakes here. So +3, +2, that means our x component is 3, our y component is 2. So that's putting our vector right here in the first quadrant. It's closer to horizontal than it is to vertical. Okay, so finding the magnitude, square root of 3 squared plus 2 squared. So that's the square root of 13. 9 plus 4 is 13. Let's just leave it as 13. Okay, to find the angle, theta equals the inverse tangent of y over x. So use our calculators, inverse tangent, 2 over 3. Theta is approximately 33.69 degrees. And that makes sense. We're in the first quadrant. 33 degrees is in the first quadrant. It's closer to horizontal than it is to vertical. Okay? So I want you to do B. I want you to find the magnitude and the